ROSEL is the largest planar RASAR antenna ever built, with an area of 40 square meters.
It's the first time we use a longer wavelength, and because of this longer wavelength, we collect new information from space that is not yet accessible or that is not yet collected by other satellites.
The first European mission to fly a software-defined radar.
Not many people know that 15 countries are involved in the building of ROSEL. This is truly a European project.
We have X-band missions, we have C-band missions like Sentinel-1, and now we have L-band missions. ROSEL, as the name implies, stands for Radar Observing System for Europe at L-band. The term L-band here refers to the wavelength that is being used. L-band is a longer wavelength, much longer than Sentinel-1. Both of them provide a different information that can be combined and gives you a better view of the Earth together. They also complement each other by flying in the same orbit and collecting information at regular intervals over the same area. So it can be used as a single system, just like we use our eyes, also as a single system, as a single way of looking at the world around us. My name is Malcolm Davidson, and I work as a ROSEL mission scientist in ESA. What kind of information does ROSEL provide? Well, it provides information on the sea ice, the different sea ice types that are there. It tells us whether ships can navigate safely, and being able to detect these ships even when there are clouds or there is darkness or indeed some storms. This information about ships is useful for security applications. It's also useful for safety applications and for ecosystem applications. One of the important ecosystem applications is, for instance, oil spills, where monitoring the oil spill, the extent of the oil spill, and the severity of the oil spill is extremely important. ROSEL also has a very good role to play in climate change or the monitoring the effects of climate change. The fact that the ice sheets are melting, how quickly they are melting, how much water is being released as they melt, are some of the questions that ROSEL helps answer. Another important area that ROSEL supports is agriculture. And agriculture is linked to food security. By providing high-resolution soil moisture information, ROSEL contributes to better crop management practices. Another important role that ROSEL plays is in terms of forest carbon stocks. When I say forest carbon stocks, I'm talking about monitoring the forests across our globe and making an inventory of how much carbon lies within these forests. ROSEL contributes to the safety of European citizens by monitoring geohazards. Geohazards are typically what we think of when we think of disasters, natural disasters, such as landslides, such as subsidence when buildings and other structures are sinking into the ground. And earthquakes and volcanoes, of course, are well known. ROSEL is able to penetrate through the vegetation with its long wavelength and sense the movements as they take place and even a little before they take place. And this type of information is inaccessible to the current generation of Copernicus satellites and is a unique characteristic of ROSEL.
In order to meet the challenging quality requirements, state-of-the-art technology is required all across the instrument. My name is Nico, I'm Nico Gebert, and my job is the ROSEL payload manager. The mission objectives of ROSEL require to image a large area, we call it a swath, with fine level of detail, so a high resolution. More specifically, the satellite can image a strip on ground of 260 km width, and one will be able to distinguish structures down to a size of 5 to 10 meters. So ROSEL is the first radar mission in Europe which will provide so much information. In addition, we need to transmit a lot of power to see also weak, so small targets on the ground. It's a bit like using a strong torch to be able to see also in the darkest corners.
ROSEL provides groundbreaking high-resolution information on ice condition in the Arctic, even in condition of complete winter darkness, supporting safe navigation.
ROSEL pierces the darkness with the help of its own illumination. It illuminates the surface below and collects information in the Arctic, even in the height of winter.
It is a combination of different techniques. For example, when receiving the echo from the ground, the antenna dynamically sweeps the beam across the ground to follow the position of the echo. At the same time, 5 different data streams are transferred to ground. This is what we call digital beamforming. We have split the large antenna into many small antennas, which we can then individually control, both when transmitting and as well when receiving the echo. It's a bit like a car, which at the same time should be small, provide a lot of space, and go fast, but with little fuel consumption. This means we needed to design an instrument which is quite special. We are developing power modules of unprecedented peak power in Europe. Such peak power requires a sophisticated design which comes with a lot of challenges. Overall, we radiate 9 kilowatts of power, which is actually enough to heat my complete house in the winter.
ROSEL, with its high challenges, is an example of the European leadership in the SAR technology, building on the Copernicus Sentinel-1 heritage. My name is Gianluigi Di Cosimo. I am the ROSEL project manager. If I have to make an example of a key technology which has been specifically developed for ROSEL, I should mention the transmit-receiver modules, which are the heart of the antenna front-end electronics. For those elements, we had to run some pre-development activities, testing that the technology was mature enough to be embarked on the ROSEL missions.
We needed to move away from classic design of radar instruments, which consists of one large antenna. In simple words, we're having 60 small antennas, which we can flexibly reconfigure by changing the software. In addition, we are transferring several data streams to the ground, which gives a lot of flexibility to process the data in many different ways. In this respect, ROSEL is truly a software-defined radar. So this specific test sample behind me, manufactured by Airbus, so it was tested over the large range of temperature variation that we see in orbit to check how much it deforms. And although the dimensions are huge, it's 2.2 meters by 30 centimeters, this sample is quite light and it doesn't weigh more than a couple of kilograms. Well, it has to be light because if the antenna gets too heavy, then the launcher could not carry it up to the orbit. So actually it's a feature of our instrument to keep the antenna very lightweight, so it's really a novel technology. Imaging such a wide area of 260 kilometers with a fine level of detail comes with a massive amount of data. On average, ROSEL will produce 6.5 terabytes of information every 100 minutes. This means almost 100 terabytes of data every day. For comparison, this would correspond to almost 4,000 hours of Netflix videos in high definition every day.
Each ROSEL spacecraft is designed to remain operational 7.5 years.
One important characteristic of ROSEL is that it is an operational mission. Operational in the sense that it acquires data all the time. It makes the data available quickly so that it can be used for the different applications. And thirdly, it follows an open data policy which supports many different new applications and enables scientists to investigate how best to use the data in new types of applications that don't yet exist but will exist in the future.
ROSEL is built by an industrial consortium of about 29 companies from 15 countries. As you can imagine, to build ROSEL is a big challenge which requires expertise, technological competence, a powerful control of all the project aspects, materials, parts and process involved. According to the current planning, ROSEL will be ready for launch in 2028.
By adding L-band SAR missions to the mix, it means that Europe will be leading the rest of the world in terms of the different frequencies and wavelengths that we have.
And it is based on the most powerful radar electronics ever, reconfigurable from ground.
Nowadays, younger generation have a high and highly ethical attention to the environment and the health of our planet. This has sometimes led to the wrong perception that technological progress may be something threatening our planet to some extent. Sentinel missions and Copernicus are the proof that technology is indeed essential and so successful in monitoring and protecting our planet. And I'm very proud of this as a European citizen and ESA staff.